Okay, hi guys, how are you doing today? Okay, so in this video we are going to talk about how to graph absolute value equations, and bear with me a little bit. It's been a minute since I've made a video, so I apologize if I seem a little out of practice. So, graphing absolute value equations, what you want to do is have all absolute values graphs are in the shape of a V. So when you make your graphs, all of them should end up in the shape of a V. So in prior or past units, we've had like the U for quadratic. So make sure it doesn't look like a U, it looks like a V. And then vice versa for when you do quadratics. You don't want those looking like V's, you want those looking like U's. So to graph these, you're going to want to make a table of values. So in order to do that, you are going to find the lowest or the highest, sorry, it's a little small, point of your graph by setting the absolute value equal to 0 and solving. So you are going to see some similarities between these and quadratic equations. So in step 1, that lowest or highest point that they're talking about is the vertex. So you have one of those with your quadratics. Then when it says to set what is, by setting the absolute value equal to 0. So that is literally everything that is inside your absolute value sign. So that's all of this stuff right here. So x plus 3 equals 0. So I would subtract 3. So x equals negative 3. And then your y value is what is going to be out here. So if you have like a plus 2 or a minus 7 or whatever, that's going to be your y value. So the fact that we don't have anything there, it's going to be 0. So plus 0. So this is your y value of your vertex. That one right there is your vertex. So then you're going to pick 2 consecutive values on either side of that low or high point to complete your table. So that meaning that we've got the negative 3 here. So let's pick negative 2, negative 1, negative 4, and negative 5. And then I would plug these values back in to get the y values of my table. So if I plug these in for x, so equals, so the absolute value of negative 2 plus 3. So negative 2 plus 3 is 1, and then the absolute value of that is still 1. So now I said that there were going to be similarities between the absolute value and the quadratic. So like the quadratic and how they mirror, they're going to do the same thing with your absolute values. They're going to mirror. So this is also going to be 1. But then they're also going to kind of mix together that pattern and then your linear pattern. So here I'm adding 1. So if I were to do that again, I'm going to get 2. And that's this over here. And you can always double check that by still going back and plugging that into your absolute value. This is just a little bit of a shortcut. Okay, and then you will graph that. So the -3, 0, -2, 1. So I always start with a vertex first when I graph, because then I can just put my points on either side of it afterwards. It makes it a little bit quicker when you're trying to graph these. And then just make sure it extends all the way to the edge of your graph and that you've got some arrows on the ends. So see how that looks like a V and not a U? So you could make that look like a U, but we don't want that look to this. Okay. So I want to try this one together because it's got a value on the outside. Okay, so step 1 is to figure out what your vertex is. So to figure that out, you're going to start by taking this and setting it equal to 0. So 2x minus 3 equals 0. And solve for x. So I'm going to do that by adding 3. Then divide by 2. So you can leave that as 3 over 2, but I like decimals a little bit better when it comes to graphing. So then this right here is my y value. So plus 1 or positive 1. So here's my vertex. Okay, and then I'm going to pick my two values above and below. So for above, so above 1.5 is 2 and then 3. So this is only 0.5 away, so I want to keep that same distance. So instead of adding 0.5, I'm going to subtract 0.5 and just have this down to 1 and then 0. So I'll get these by plugging back in my values. So absolute value of 2 times 2 minus 3, then plus 1. So this is my y. So 2 times 2 is 4. Then 4 minus 3 is 1. And the absolute value of 1 is still going to be 1. So then plus 1 is 2. And remember, they mirror. And they're going to have that same pattern. No. Oh. So this one here, they all go up by 1, or actually down by 1 technically because they're negative. But here we go down by 1, and then down by 0.5, and then down by 0.5, and then down by 1. So they are still going to mirror, but it's not going to be like a +1 because the distance between here and here is different than the distance between here and here, if that makes sense. So just to be safe, let's plug in our value for 3 just to kind of show you. So 2 times 3 minus 3 is 1. So 2 times 3 is 6 minus 3. So 6 minus 3 is 3, and the absolute value, that's still going to be 3, plus 1 equals 4. So see how that wasn't the same, and that's because that distance, again, wasn't the same. So 1.51, then 1, 2, and 0, 4. Okay. So now I want to go ahead and do this one just because it's got a negative on it. So I wanted to do that one for an example as well. Okay, but we will start by taking what is inside the absolute value only. So you don't take everything else and set that equal to 0 and solve. So subtract 3. So x equals negative 3. So there is no value out here, so there's like that +0, so that's going to be my y value of my vertex. So then I pick 2 values above and below that. So -2, -1, -4, -5. And these are all going by 1, so we should be able to then also figure out what our pattern is. So if I plug in -2, -2 plus 3. So -2 plus 3 is 1. And then the absolute value of that's still going to be 1. But there's this negative out front that you need to keep. So this should be a -1. Should be the same here. So I subtracted 1. So if I did that again, this is going to be -2. So your negatives on the outside should flip your graph. Okay. So I want you to go through and do the other 3 as practice. Okay, and then tune in for the next video. Hey, have a good day.